In this lesson, we're going to talk about adding and subtracting radicals. And what we need to think about radicals as, we need to think of them as being similar to variables. And the rules that apply to adding and subtracting variables applies to adding and subtracting radicals. In other words, we can't add and subtract radicals unless they're alike radicals, okay, unless they're the same. So if we look at this, we have 4 squared is 7 and 5 squared is 7. So you can use the distributive property to simplify 4 square root of 7 and 5 square root of 7 because each term has square root of 7 as a common factor. Okay, so this would be the same as square root of 7 times 4 plus 5. Okay, 4 plus 5 is 9, so that would give me 9 square root of 7. Think of this in terms as if it were x's. If I had 4x plus 5x, well, we would say, well, that's just 9x. The radicals work the same way. Okay, these two radicals are the same, which makes these two terms like terms, so I can add them, and what I do is I just add the coefficient. The radical just stays the same, just like the x would stay the same in this case. So here I have a bunch of radicals that I'm adding together, and notice that these two are like terms because they're both square root of 6. This one is not. So the first thing I'm going to do is look at this and see, can I simplify this so that I have the same radical? And I can't because 13 is a prime number, so I can't factor anything out. So what I'm going to do is I'm going to add my like terms. So these are my like terms. I have 3 square root of 6 and 5 square root of 6, which gives me 8 square root of 6. And I'm going to subtract the 2 square root of 13. And that's all I can do. There's nothing more that I can do with that. So that is simplified. Here I have 7 square root of 3 minus 4 square root of 6 plus 2 square root of 48 minus 6 square root of 54. I'm going to see if I can simplify these two because they just look pretty big to me. So I have 7 square root of 3 minus 4 square root of 6. I know I can't simplify those any further. Well, the square root of 48 is the same as 16 times 3. And 16 is a perfect square. And then the square root of 54 is the same as 9 times 6 because 9 is a perfect square. So this is going to give me 7 square root of 3 minus 4 square root of 6. Brighten this up a little bit so you can see it. Square root of 16 is 4. 4 times 2 is 8, so this is 8 square root of 3. Square root of 9 is 3. 3 times 6 is 18, so minus 18 square root of 6. So now I have 7 square root of 3 plus 8 square root of 3, which is 15 square root of 3. I have negative 4 square root of 6 and negative 18 square root of 6, which is going to give me negative 22 square root of 6. Okay, so I treat them as if they were variables. I want to have this as simplified as possible, and then I just treat my radicals as if they were variables. And if they're like terms, I can add or subtract them. If they're not, I can't. Okay, so here's a couple little rules. To simplify sums or differences of square root radicals, express each radical in simplest form. So that's what I did with these two. I expressed them in their simplest form. And then I used a distributive property to add or subtract radicals with like radicands. So basically that's like terms. Okay, we're just looking for things with like terms, same radicals that we can add or subtract. All right, so that's pretty much it. So let's look at our proof. We have 8 square root of 11 plus 2 square root of 11. Because they're both square root of 11, they're like terms. So I add the coefficients. 8 plus 2 is 10. So it's 10 square root of 11. Think in terms of the distributive property. Okay, that's why I'm allowed to do that. If I look at this one, I have a square root of 3 here and a square root of 3 there. So 7 square root of 3 minus 1 square root of 3 is going to give me 6 square root of 3. Here I have a square root of 2 and another square root of 2. So 2 minus 3 gives me negative 1 square root of 2. So this is in simplest form. And if I look at my last one, these two I think I can simplify. So I have 25 square root of 2 plus 27 I can factor into 9 times 3, and 98 I can factor into 49 times 2, 49 being a perfect square. So I have 25 square root of 2 plus square root of 9 is 3. 3 times 2 is 6. So 6 square root of 3. Square root of 49 is 7. 7 times 3 is 21. Square root of 2. Now these two are my like terms. So 25 minus 21 gives me 4. So I have 4 square root of 2 plus 6 square root of 3. I don't have any more like terms. So that is my solution.